This is SpaceTime Series 27, Episode 65, for broadcast on the 29th of May, 2024. Coming up on SpaceTime, intriguing new features discovered in new images of the Jovian ice moon Europa, a new model to explain the formation of free-floating planets, and the Mars Perseverance rover collects its 24th rock sample on the Red Planet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New images of the Jovian ice moon Europa, taken by NASA's Juno spacecraft, have turned up some intriguing features. The new observations from the spacecraft's Juno visible light camera support the hypothesis that the icy crust at Europa's north and south poles is not where it used to be. Meanwhile, another high-resolution image of the icy moon, this one by Juno's Stellar Reference Unit, has revealed signs of possible plume activity and an area of ice shell disruption where brine may have recently bubbled onto the surface from the moon's deep subsurface global liquid water ocean beneath. The findings, reported in the Planetary Science Journal, could provide opportunity for a spacecraft to collect samples of geyser material which may have originated in the underlying ocean. That would allow scientists to determine what the ocean's made of and whether it could support life. The new images represent the first high-resolution images taken of Europa since the Galileo spacecraft's last flyby in the year 2000. Juno made its closest flyby of Europa on September the 29th, 2022, coming to within 355 kilometres of the moon's frozen surface. Juno's ground track over Europa allowed imaging near the moon's equator. When analysing the data, the JunoCam team found that along with the expected ice blocks, walls, scarps, ridges and troughs, the camera also captured irregular steep-walled depressions between 20 and 50 kilometres wide. They resemble large ovid pits, previously already seen in imagery from other locations on Europa. Now, these surface features have been associated with true polar wander, a theory that Europa's outer shell is essentially free-floating on the surface of the underlying ocean, and because of this, it moves around from place to place. True polar wander would occur if Europa's icy shell is decoupled from its rocky interior, resulting in high stress levels on the shell, which lead to predictable fracture patterns. JunoCam co-investigator Candy Hansen from the Planetary Science Institute in Tucson, Arizona, says it's the first time that these fracture patterns have been mapped in Europa's southern hemisphere, suggesting that true polar wander's effect on Europa's surface geology is far more extensive than previously identified. The high-resolution JunoCam imagery has also been used to reclassify a formerly prominent surface feature from the Europa map. Hansen says that crater Gerwin is no more. What was once thought to be a 25-kilometre wide impact crater, one of Europa's few documented impact craters in fact, was instead shown to be nothing more than a set of intersecting ridges that created an oval shadow. Although all 5 of these new Europa images from JunoCam are high resolution, the image from the spacecraft's black and white Stellar Reference Unit offers the most detail. Designed to detect dim stars for navigation purposes, the Stellar Reference Unit is sensitive to low light. To avoid overillumination in the image, mission managers used the camera to snap night-side images of Europa while it was being lit only by sunlight scattered off Jupiter, a phenomenon known as Jupiter shine. This innovative approach to imaging allowed complex surface features to stand out, revealing intricate networks of cross-cutting ridges and dark stains from potential plumes of water vapour. Juno executed its 61st close flyby of Jupiter on May the 12th. Its 62nd flyby of the gas giant is scheduled for June the 13th and includes an Io flyby at an altitude of 29,300 kilometres. One intriguing feature on Europa, which covers an area of 37 by 67 kilometres, has been nicknamed the platypus because of its shape. Characterised by chaotic terrain with hummocks, prominent ridges and dark reddish-brown material, the platypus is the youngest feature in its neighbourhood. Its northern torso and southern bill, for want of better terms, are connected by a fractured neck formation and interrupt the surrounding terrain with a lumpy matrix material containing numerous ice blocks up to 7 kilometers wide. Ridge formations collapse into the feature at the edges of the platypus. Now, for the Juno team, these formations all help support the idea that Europa's ice shell may be giving way in specific locations where pockets of briny water from the subsurface ocean are present just beneath the surface. About 50 kilometers north of the platypus is a set of double ridge features flanked by dark stains similar to features found elsewhere on Europa, which scientists have hypothesized could be cryovolcanic plume deposits. Taken together, these features are hinting at present-day surface activity. The Stellar Reference Unit's image is a high-quality baseline for specific places NASA's Europa Clipper mission and ESA's JUICE mission can target to search for signs of change and brine. JUICE, the Jupiter Icy Moons Explorer mission, is already a year into its 8-year journey. Launched back in April last year, the ESA mission will reach Jupiter in July 2031 to study Jupiter's 3 large icy moons, Callisto, Ganymede and Europa. It'll also look at the fiery volcanic world of Io and some of Jupiter's smaller moons, along with the gas giant's atmosphere, magnetosphere and rings. But the mission will have a special focus on Ganymede. Of course, the other big mission focusing on Jupiter will be the Europa Clipper, which, as the name suggests, will be targeting Europa and investigate whether the ice moon could have conditions suitable for life. It's scheduled to launch between August and October this year, arriving in the Jovian system in 2030. This report from NASA TV.
Everywhere on Earth that there's water, there's life. We have several ocean worlds in our solar system. And by exploring Europa, we're getting a taste of what these ocean worlds are like.
Europa is one of the moons of Jupiter. It's about the same size as our own moon, a little bit smaller, but it's so much different. It's an ice world.
Europa probably has beneath its icy surface a global ocean of water.
We think there are thermal vents in this vast subsurface ocean. There may be primitive organisms there, similar to the original primitive organisms on Earth from which we all evolved.
When we first discovered hydrothermal vents on our seafloors on the Earth, we also discovered life. There was no sunlight that was penetrating down that deep, but yet there was life living there.
On Europa, we're not looking for life itself, we're just looking for an environment in which life could thrive.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are very few, shockingly few impact craters. So that means something is going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening.
The Europa Clipper mission will be the first in-depth exploration of an ocean world.
Europa Clipper is orbiting Jupiter, and it's performing 49 flybys of Europa. And the main reason it's doing that is to stay mostly outside of Jupiter's really intense radiation belts.
Each time we make a flyby, we turn on all of the instruments at once.
Most of us know about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near infrared, the far infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and determine the composition with extreme precision. We're looking for signs of organics at Europa. Are there materials that contain carbon and hydrogen and oxygen and nitrogen? And we have another instrument that can tell us the composition of dust particles. We're pretty sure there are salts on Europa's surface, and those salts may have come out of the ocean. We want to understand what are those salts.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice-penetrating radar that will try to get below the ice shell.
Last but not least, we have a gravity experiment using the communication system of the spacecraft. And from that, we can get essentially a map of the gravity field.
We can get the shape, understand, what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
So there really has not been a mission like Europa Clipper. The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
I have no idea what we are going to detect beneath Europa's icy surface, but all I know is it's going to be wonderful.
We do this work of exploration for the next generation. We don't know if Earth is the only place that life got started, or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?
And in that report from NASA TV, we heard from Europa Clipper project scientist Robert Pappalardo, Europa Clipper deputy project scientist Bonnie Baratti, Europa Clipper staff scientist Kate Kraft from the Johns Hopkins Applied Physics Laboratory, Europa Clipper staff scientist Aaron Leonard, and Europa Clipper investigation scientist Sean Brooks. This is Space Time. Still to come, a new model for free-floating planets, and NASA's Perseverance rover collects its 24th sample of the red planet. All that and more still to come on Space Time. Astronomers believe that gravitational perturbations between stars in dense clusters could wind up flinging orbital planets out of their birth systems and into interstellar space. The recent discovery of a potentially new class of distant and mysterious free-floating Jupiter-sized planets by the James Webb Space Telescope has intrigued astronomers. These candidate rogue planets have been named Jupiter Mass Binary Objects, or JUMBOs. They seem to orbit one another as they float freely in space, unbound to any host stars. And that counters prevailing theories of how planetary systems were thought to work. Now a report in the journal Nature Astronomy suggests a new model to try and explain how these jumbos may have formed. The study's authors used advanced techniques known as direct n-body simulations to explore how interactions within dense stellar clusters could lead to the ejection of giant planets that remain gravitationally bound to each other as they drift through the galaxy. The research offers a new model for how these enigmatic binaries may form, in the process filling a critical gap in science's understanding of planetary evolution. The simulations demonstrate that close stellar encounters can spontaneously eject pairs of giant planets from their original systems, leading them to orbit each other in deep space. The study's lead author Yan Wang from the University of Nevada, Las Vegas, says these findings could significantly alter science's perception of planetary dynamics and the diversity of planetary systems. The research suggests that such events are more likely to occur within densely populated star clusters, and as there are an awful lot of star clusters out there, it suggests that free-floating binary planets could be much more common than previously thought. The characteristics of these planetary pairs, such as their separation and orbital eccentricity, provides new insights into the violent environmental conditions that influence planetary formation. It introduces dynamic stellar interactions as an important factor in the development of unusual planetary systems, especially in dense stellar environments. The authors say that the new work broadens what astronomers already know about planetary formation and sets the stage for future observations with the Webb Space Telescope that could provide further evidence supporting the team's predictions. This is SpaceTime. Still to come, Perseverance collects its 24th rock sample on the red planet, and later in the science report, a new study warns that fish oil supplements have been associated with a 13% increased risk of developing atrial fibrillation. All that and more still to come on SpaceTime. NASA's Mars Perseverance rover has just collected its 24th rock core sample in Jezero crater. After investigating the high-standing bedrock at the Bunsen Peak workspace deep within the crater's margin unit, the unique nature and composition of this rock was deemed worthy of collection. Bunsen Peak's named after a prominent mountain in the Yellowstone National Park. They say the core is especially exciting because it appears to be composed primarily of two minerals, carbonate and silica. Carbonate and silica are both excellent minerals for preserving ancient signs of life. These minerals also have the potential to record the environmental conditions in which they formed, making them important minerals for understanding the habitability of Jezero crater billions of years ago, at a time when Mars was a warm, wet world compared to the freeze-dried desert it's become today. The presence of carbonate within the sample suggests that water, carbon dioxide, and chemical elements derived from rocks and sediments in the area once reacted here to form carbonate. Carbonate minerals from Earth's rock record are often used to reconstruct ancient climate, including conditions like temperature, the amount of precipitation an area receives, or how arid it is, and the history of any life there. At the same time, silica phases form when water interacts with rocks and sediment. The composition and crystallinity of the silica can reveal the extent of the interaction with the water, such as the intensity or duration of its weathering and the pressure and temperature conditions during its formation. On Earth, biosignatures can be preserved in carbonate and silica for millions of years, even billions of years in the case of silica. In fact, some of the oldest evidence we have for life on Earth is from rocks containing fragments of microbial cells that were mineralized by silica, a fossilization process that entombs the residues of ancient life and protects them from degradation. So rocks containing these minerals are considered among the highest priority samples for investigating whether Jezero crater could have once been host to microbial life. Perseverance's 24th core samples from Bunsen Peak represents a significant milestone towards the collection of a scientifically diverse set of samples which will hopefully eventually be returned to Earth as part of a Mars sample return mission. With rock core sample 24 now on board, Perseverance is pressing forward towards its next strategic objective, an investigation of a location known as Bright Angel, which is a light-toned outcrop of exposed ancient rock in the channel wall of the Narrativa Valleys. However, challenges may arise on this journey, as the terrain ahead is littered with sharp boulders and sand that are proving difficult for the rover's auto-navigation system. It means mission managers are working hard to manually navigate this tricky terrain now that the Ingenuity rotocopter is no longer available to scout out the terrain ahead. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims that while fish oil supplements can be beneficial for those with heart problems, their use has now been linked to the opposite effect for those with a healthy heart. The surprising findings, reported in the British Medical Journal, claim the evidence is mixed on the impact omega-3 fatty acids, or fish oil, has on the heart. So they track the heart health of over 400,000 middle-aged people over a decade and whether they use the supplements. The authors say that among those with a heart disease diagnosis at the start of the study, fish oil supplements were associated with a reduced risk of heart problems becoming more serious, such as leading to a heart attack or death. However, among participants with no heart problems at the start of the study, fish oil supplements were associated with a 13% increased risk of developing atrial fibrillation and a 5% increased risk of stroke. Researchers say their study doesn't show if fish oil is the cause of this increased risk, but it does suggest that fish oil may have a different role for different stages of heart disease progression. It seems a famous strip of ancient Egyptian pyramids could be a clue to pointing to a long-lost branch of the River Nile now buried under farmland and desert. A report in the journal Communications, Earth and Environment has found that 31 pyramids, including the famous Giza complex, have sat for over 4,700 years in a strip on the edge of the unlivable Western Desert. The authors say others have already speculated that the Nile likely once split into several more branches than it does now, and that one of these may have flowed by the pyramids. Using satellite imagery and surveys of the area, the researchers say they've now found evidence of river sediments beneath the surface, supporting the theory of a long-lost river branch. They say it's possible a major drought some 4,200 years ago led to the migration of the river and a buildup of sand, which eventually buried this region. A new study has finally confirmed what we've all known for years. Twitter, under the control of left-wing activist Jack Dorsey, appeared to have been overlooking misinformation being posted by so-called super spreaders. The findings, reported in the journal PLOS ONE, are based on an international study which analysed more than 2 million tweets over a 10-month period in 2020. That's before the platform was bought by Elon Musk and transformed into X. The team set out to analyse these tweets in order to build on previous research which found that a disproportionate amount of low credibility content was being spread by a very small number of accounts. The analysis found that these so-called super spreaders include pundits with large followings, low credibility media outlets, personal accounts affiliated with those media outlets, and a range of influencers. They were primarily political in nature and used more toxic language than the typical user sharing misinformation. Of course, it was under Jack Dorsey's management that Twitter was commonly regarded as social media's toilet door. The authors found evidence that Twitter was more lenient on super spreaders who were verified and those who had large followings, and this was due to political pressure. There are growing concerns that Microsoft's new recall feature, which monitors your every computer activity, supposedly to bring you a quicker and more accurate search result, actually makes it a lot easier to spy on your computer activities. The new artificial intelligence tool will be added to Windows 10 and 11 users, remembering and understanding everything you do on your computer by taking constant screenshots. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
So they've launched their new Copilot Plus PC initiative with Windows 11 that has this new recall feature, which has caused controversy. It will take screenshots of what you're doing, presumably every few seconds, if not more regularly, and it will then encrypt those images, process them locally, not train them for advertising or AI, external AI that is, but it will be used internally. We'll look at those images, and if you search for an expensive handbag for your partner or some item of clothing, or you've got a PowerPoint presentation that had some purple writing with an arrow on it, but that's all you can remember about those particular things, you'll be able to type those descriptions in, and the AI can look through all the snapshots taken of all the things you've been looking at on your computer whilst you've been working and find those things for you in ways that a simple search...
Wouldn't a quick search in history do the same thing?
Not necessarily, because you may not have the terminology blue dress in the web search that you had there, because it may have been a particular brand of dress and it may not have had the descriptor in any of the information you were searching. But because it is... I can imagine
many suspicious partners finding this particular application most useful.
Well, you are able to tell the AI not to look at certain things that you are looking at this moment. You can turn the AI's ability to take snapshots off. You can also delete anything that has been taken a record of. But the whole idea is that you can have this visual search based on images that the computer is taking of what you're doing in a way that AI can give you that answer in a way that maybe a normal description for something cannot. Because you may have worked on a document or an email a few weeks ago or days ago, and we've all had the experience where we're trying to find that image or document or spreadsheet or whatever it is, and we spend hours was looking for it, only to eventually find it sometime later. This is meant to speed up that whole process thanks to AI. And of course, people are concerned, what if those images are hacked? But you can go back and slide yourself through a timeline of everything you've ever seen, so you can look at it visually yourself. And it's all meant to be encrypted and stored locally. But look, how soon this will be hacked by somebody, and then every image that you've ever saved on the computer through that process being siphoned off is all yet to be seen.
Apple, they're just launching new operating systems and updates for their devices.
A couple of weeks ago, they launched all these new updates with plenty of bug fixes to close up security vulnerabilities that if you haven't updated and the bad guys target you with some sort of an app or something to basically try and break into your phone. Well, the 17.5, for example, on iPhone and iPad closes those holes. But there was a bug in 17.5 that allowed older photos you had deleted. That could have been personal photos you wanted nobody else to see, or just photos you remember that you deleted a long time ago. And suddenly, they're reappearing under 17.5. Now, the 17.5.1 update closes this bug, but I thought if you deleted photos permanently off all your devices, including iCloud, why are they suddenly reappearing? So Apple hasn't specifically, officially explained why, other than some sort of a database corruption, which sounds a bit nefarious. But if you upload something to the cloud, is it ever truly deleted? Is it at the NSA somewhere? Is there a backup copy on a bunch of different servers that Apple and Microsoft and Google have to make sure that if anything ever goes wrong, they can get your data back? Well, are they keeping copies of your data? So a bit of a weird one from Apple here to have these
the
photos.
Is yes.
Well, yes, it seems it could be the case.
The name Nokia has resurfaced and they've launched some new Android smartphones.
Yeah, Nokia actually resurfaced with their smartphones 2 or 3 years ago, but they did it through a company called HMD, called Human Mobile Devices. And Nokia's new Android phones have been quite a hit. They were bringing back the Nokia brand name and the quality, and they relaunched some of the feature phones, the flip phones, the candy bar phones. And the company has been doing very well and even introduced phones that you could buy a kit from iFixit for about $50 to prize open your phone. It takes longer than just peeling off the old Nokia cases of old from 20 years ago, but you could pull the phone apart, and then from iFixit, you could order a screen, a replacement screen for $75, a battery for around the same price, the little USB-C port if they got somehow damaged. And so Nokia has made phones that have been very easy to repair, which is really important because no one else is doing that. You've got to take it to your Apple or Samsung store and they charge you a lot more money. And the HMD brand has decided that, yes, it's still selling Nokia phones, but for its lower-end devices, it's going to go with the brand name HMD. So they have the Pulse, Pulse Plus, and Pulse Pro. They're $229 in Australian dollars, $259 and $299. So very affordable. Obviously, they will not have the AI super smarts of the Galaxy S24 range. They won't be as performant as an iPhone 15, for example. But for the money, they will do everything you need it to do: the phone calls, the apps, the Waze, all the different emails, everything sort of the standard person would want to do. And they have 50 megapixel front and back cameras, large screens, and of course they're easily repairable. And they have this great value proposition that it only has 2 years of Android updates, whereas Samsung has 4 years, Google has 7 years, for example, on its different devices. I think Samsung has more on its flagships, 5 or 7 years as well. But if you're only paying $299 for the phone, then in a couple of years you don't mind spending another $299 to get whatever the newest one is at that time. So yes, not as powerful as the newest devices, none of the AI bells and whistles aside from within the camera, but a push towards inexpensive, affordable repairability.
That's Alex Zaharov-Reutt from Tech Advice. Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.